For decades, our understanding of Saturn was stable. It was the crown jewel of the solar system, a predictable gas giant whose rings and moons seemed to follow the standard, well-documented rules of planetary physics. To confirm those theories with physical evidence, NASA launched the Cassini mission. It arrived in 2004 as the most advanced, heavily funded expedition ever sent to the outer planets, designed to map a system we thought we already understood. But as Cassini moved into orbit, the data it returned began to deviate sharply from decades of theoretical physics. The closer we looked, the less the observations matched the math. Saturn isn't just a planet with unique features. It is a collection of physical anomalies that actively defy the models we use to explain the rest of the universe. At the very top of the planet sits a permanent, six-sided geometric structure. This polar hexagon is a massive cloud formation, wide enough to contain 4 Earths, that maintains a rigid, geometric shape while spinning. Researchers attempted to replicate this on Earth. Professor Peter Reed used a spinning disk inside a tank of liquid to simulate Saturn's jet streams, trying to force the fluid into a stable, multi-sided shape. Physics require whirlpool vortices, acting like pins, locking the corners to prevent the hexagon from collapsing. But Cassini found no vortices at all. Without those whirlpools to hold the corners, current models of fluid dynamics suggest the entire structure should collapse into a circle. Yet, the hexagon remains perfectly stable. It is a physical structure that persists despite the absence of the very mechanisms we believe are necessary to hold it together. Further out, in Saturn's icy F-ring, Cassini discovered a different kind of disruption within a band of debris that usually resembles thin, braided wire. In 2016, a 30,000 square mile hole appeared in the ring material. It looked as if an object had blasted through the ice, leaving a chasm large enough to hold Lake Erie. Astronomers initially looked to the moons Prometheus and Pandora. These small bodies orbit on either side of the F-ring, and their gravity typically polices the shape of the debris. However, orbital data showed that Prometheus was on the opposite side of the planet when the puncture occurred, making it physically impossible for that moon to be the cause. This chart compares the mass of Pandora to the force required for a disturbance of this scale. While Pandora was in the area, its gravitational pull is mathematically dwarfed by the force needed to blast 30,000 square miles of ice out of orbit. Gravitational models require a massive object to create a puncture this large, yet Cassini's cameras found nothing in the vicinity. The cause of the collision remains physically absent. Then there is Mimas. It is a small, frozen moon dominated by the Herschel crater, a feature so large it gives the moon the appearance of the Death Star from Star Wars. As Cassini tracked the moon's orbit, it detected a strange vibration. Mimas wobbles significantly as it travels, a motion that shouldn't occur in a standard solid body. One theory suggested that the massive impact that created the crater also shifted the moon's internal density, creating a mass anomaly that unbalances its rotation. This data shows the conflict. The first bar represents the maximum wobble an impact could cause. The second bar shows the actual observed vibration, which is exactly twice as large as the impact model allows. The only other scientific explanation for a wobble of this magnitude is a liquid ocean sloshing deep beneath the surface, much like the one found on the neighboring moon Enceladus. But that theory creates a new contradiction. Moons with liquid interiors eventually settle into perfect circular orbits. Mimas, however, maintains a distinctly elliptical path. Mimas presents a paradox that breaks both models. It wobbles as if it's full of liquid, but it orbits as if it's frozen solid. On Titan, Saturn's largest moon, the contradictions move to the surface. Giant dunes of frozen hydrocarbons, some as tall as the Statue of Liberty, stretch across the equator. Atmospheric models show that Titan's winds blow from east to west. Curiously, the dunes themselves are shaped and oriented as if they are marching from west to east, the exact opposite direction of the wind. The resolution is found in electricity. The wind generates a massive static charge as it blows. causing the hydrocarbon grains to clump together and hold their shape even against the prevailing winds. This electric environment suggests a unique path for biology. On Earth, we have discovered microbes that eat and breathe pure electricity. On Titan, the gravity is only 1/7 of Earth's, which removes the physical weight limits that keep Earth's organisms small. Because of that low gravity, simple organisms capable of consuming raw electrical energy could theoretically scale up to enormous sizes, potentially creating a world inhabited by massive creatures that thrive on power alone. The anomalies Cassini found across the Saturnian system highlight a gap between our theories and reality. Our mathematical models were built using the physics we observed on Earth. Saturn is a reminder that the rest of the universe is under no obligation to follow those same local rules. In 2034, NASA's Dragonfly mission is scheduled to land a rotorcraft on Titan to investigate these electrical dunes and the chemistry beneath them. We are returning to the system that challenged our understanding of physics, not to find the answers we expect, but to learn the new rules of the cosmos.